Unit conversions, a very important topic going forward. If you haven't watched the equivalent fractions videos yet, go back and watch that. So, here we go. So if we're going to talk about unit conversions, we need to know what a unit conversion is. So, unit. In this case, well, in all cases, a unit can either be is something we're measuring. So whether we're dealing with measuring distances, so like feet, meters, inches, whatever we're measuring with. If we're measuring a distance, if we're measuring a volume, it would be liters, gallons. If we're measuring the amount of people, then our unit would be people we're measuring. If we're measuring the amount of marbles in a jar, whatever we're measuring is what our unit is. So marbles in that case. If we're measuring distance, it's miles. If we're measuring hairs on your head, it's hairs. It's the subject. It's the thing we're talking about. So conversion. What's a conversion? We converting something, going from one thing to the other. In the case of units, we are going from one measurement to another. So for example, if I measure something to be 1 foot and we wanted to convert it to inches, we'd be converting 1 foot to 12 inches. That's a conversion. If we wanted to convert meters to centimeters, 1 meter is 100 centimeters. We're changing the unit, and if you also notice, we're changing the amount we have. So, write that down. Okay. So let's take a look at what we have going on. Let's use a basic example, one I already mentioned. Let's convert feet to inches. Feet to inches. Now there are three, I'm just making this up on the spot now, so if I have to add to it later, beware. But there are three important things to know when you get started with your unit conversion. Number one, what unit we're starting with. Number two, what unit we're ending with. And three, the rule that connects them. Rule that connects them, or we can call that a relationship. I'll probably say that most often, or an equation. So let's take a look at what we got. So if we want to convert feet into inches, we know our starting unit, we know our ending unit, but what is the rule that connects them? What's our equation that connects feet to inches? What's the relationship between feet and inches? So I'll just give this one to you, and you'll just think about future ones. So 1 foot equals 12 inches. Okay. That's a rule. We know that 1 foot equals 12 inches. It's an equation, and it's also a relationship. So I'll show you how we use this in a second. Now most math books would probably just teach you to multiply or divide in this case, and then later make it more complicated. What I'm going to do is I'm going to show you the whole long structure. It's not too much longer. It's just going to look a little unnecessary. But if I teach you this first, it's going to make learning the extra stuff later even easier. So just keep that in mind. It might look a little unnecessary, but it's going to help you in the long run. So let's go ahead and set up our problem now that we have our three parts: our start, our ending, and our rule. So, well, we also need the question. So let's take, for example, we have the question, 2 feet equals how many inches? So what's our starting unit? Well, we have 2 feet already. Equals how many inches? We don't know. So that makes it our ending unit. Starting unit is usually the one where we have information already. We have a value. And so we want to start with feet, we want to go to inches. Now, here's an important thing too that most math books won't teach you. What I want you to do is I want you to think of each unit as its own variable. So just like how we have 2x or 2y, I want you to think of 2 feet in the same way, except instead of thinking as f and t as two different things, think of them as one variable itself, okay? But don't worry about the parentheses. So I just want you to treat it like a variable in the sense that it has coefficients, and we can work with it like that. And I'll show you, that'll make your learning so much easier for topics like this. So this is how we're going to set up the problem. So starting unit, what do we have? We have 2 feet, okay? Now, what I want you to do, it seems unnecessary now, but it's going to be very helpful later. I want you to go ahead and write it as a fraction. 2 feet equals 2 feet over 1 if we wanted to make it a fraction. And we want to get to the point of inches. We want our ending units to be inches. We don't know how many yet, although you probably figured it out, but let me just show you the process. This is something I like to do too. Start with the easy examples so you can see how it works. That way later when you get a more complicated example, you can go back to the easy problem. So that's why I give you pretty easy examples. You might go, oh, I already know this. I don't need to work it all out. We work it all out as a guide so that later, if we get stuck, we can see the easy example and remind ourselves and see how everything moves. So, okay, so this is what we got. We got our starting unit written as a fraction. We got our ending unit. We don't know what our numerator is. We don't know what our denominator is. Or we can say coefficient, since we're treating inches as a variable as well. Or we can say, you know, the value, how many inches. Okay, so we want to multiply by something, another fraction, so that we get to inches somehow. Now, two principles are going to come into play right now. One, the rule of equivalent fractions. So, like I said, watch that video. We're going to use some of the topics from that. Number two is factor cancellation, and I'll show you how both these tie together. But just keep those in mind. I'll write it down. Now, why would equivalent fractions come into play here? Because if I measure some, let me pull out my fancy ruler. Where's it at? It's stuck. Please hold. Paint. Is that backwards on your screen? It's frontwards on mine. Let me know in the comments. Okay, so why do equivalent fractions come into play here? Let me make sure you can see me. Okay, so right here I have 2 feet. Okay. Oh, shoot. I can't even get that far away. Okay, just take my word for it. It's 2 feet, okay? Where my finger is. If I measure this hole puncher, oh my gosh, nothing's in frame today. If I measure this hole puncher, I have an idea. This is going to get crazy. It's huge. Okay, so can you see this now? Better. Okay, look how big I am. This is the first time we go full screen in a video. Aww. Okay. Okay, this is 2 feet right here. Let's say I measure this hole puncher. Would have been nice if it was 2 feet, but it's not. Okay. I gotta, if I hold it, oh, look, now it looks like it's 2 feet long. If I measure this hole puncher and it's 2 feet, and then I say, no, I want to measure it in inches. Well, spoiler alert, it's 24 inches. So if I measure it in 2 feet, and then measure it again, and I'm like, no, it's 24 inches, did the length of my hole puncher ever change? No. It was the exact same thing we were measuring. The only difference is we were using 2 different units, and that's why we had 2 different values. 2 feet versus, what's 24 in sign language is 24 inches, okay? That's why they're equivalent, because even though they're 2 different values, 2 versus 24, they're still measuring the exact same thing. They're still measuring the same distance. So they're equivalent, they just look different, just like when we have equivalent fractions with common denominators and stuff like that. So that's why we're able to use our equivalent fraction rules in this case. I'm all tiny again. Woo, tiny brace. That was dumb. I shouldn't have done that. Okay, so we need to multiply by something so that we turn our feet into inches. So remember, what's special about the thing we multiply in equivalent fraction problems? It's equal to 1. Why does it equal 1? Because the top is going to be equal to the bottom. Like when we multiply by 4 over 4, whenever we do that, it's equal to 1 because 4 divided by 4 is 1. But in our case, this is where our rule comes into play, our rule. So we know that 1 foot equals 12 inches. That equal means they're the same. So we're going to put that over here in our fraction. We're going to put 1 foot in our denominator and 12 inches in our numerator. I'll explain why in a second. But look, do you agree that this is equal to 1? Maybe not if we use regular math, but in our mind. If we have 12 inches, is that the same as 1 foot? Yes. So if we divide something by itself, we know that that equals 1. So this is why we're able to multiply by this. Why this is helpful is for this reason. So we want to multiply across. We have 2 feet times 12 inches over 1 foot times 1 times 1 foot. Now, remember, I said I want you to treat these like variables. So if we're dealing with a multiplication or a fraction or division problem, and we have something that's the same in the top and the bottom, what do we do with that usually? We can cancel it. So if we have feet in the top and feet in the bottom, we can cancel it because we're treating it like a factor. Think of it as 2 times a foot equals 2 feet, right? 1 times a foot equals 1 foot. 12 times an inch equals 12 inches. Think of it, you can kind of think of it as multiplication. And if it's multiplying, that means it's a factor. If it's a factor, that means if it's the same in the top and the bottom, we can cancel it. So we got rid of our feet. Now, is there anything else we can cancel? No. Let's multiply across. What is 1 times 1? 1. What is 2 times 12 inches? Don't get confused by the inches just yet, because just treat it like any other variable. So think, what's 2 times 12? 24 times inches, 24 inches. And then we got 24 inches over 1 equals 24 inches. All right. So we set it up like, let's reiterate what we did. Started with what we had. We went to where we're going. We did equivalent fraction multiplication using our rule, and we were able to cancel our units because they were the same in the top and the bottom, and we were left over with the unit we needed. And now we see we started with 2 feet, we ended with 24 inches. 2 feet equals how many inches? 24. Pretty neat, right? Okay, let's do another example. Okay, let's do one more example, but this time going from inches to feet. So if I said, I'll write it down, 9 inches equals how many feet? Gee, I don't know. Okay, let's do our 1, 2, 3. 1, 2, 3. What units are we starting with? 9 inches. Well, inches is the units. There's 9 of them. What are we trying to get to? Feet. We don't know how many yet. What is our rule that connects inches and feet? 12 inches equals 1 foot. Now, I know this is the same one we used last time, but it doesn't have to be this. Maybe you want to use 24 inches equals 2 feet. It doesn't matter what you use so long as they're both equal. But usually you want to have one of them equal to 1 because that's the simplest way to do it. Okay, let's set up our problem. We start with the unit we have, 9 inches. Turn it into a fraction. It's all 9 inches over 1. We need to know where we're going. We're going 2 feet. We don't know how many yet. And we need to multiply by something. So using our rule, we got 12 inches equals 1 foot. But do we write 12 inches on top or 12 inches on the bottom? Well, we need to be able to cancel out these inches because we only want feet to be left over. So the only way to do that is to have inches in the bottom. Whatever you're canceling needs to go into the bottom. Whatever you want to get to has to be on the top. So we'll write it that way. 1 foot over 12 inches. Okay, let's do some cancellation. Inches, inches, we're gone. Can we cancel anything else? Yep. 3 goes into 9 3 times. 3 goes into 12 4 times. Let's multiply across. 3 times 1 foot gives us 3 feet. 1 times 4 gives us 4. We got 3 feet over 4, which doesn't make much sense, but we can just treat it like a fraction. 3 over 4 feet, 3/4 of a foot. And if we look at our ruler again, there's a foot. Wrong way. There's 9 inches, and if we look, that's about 3/4 of the way to a foot. I know those are 2 basic examples. I can make more complicated examples later, but for now, that's enough to get you going to know how to start working with units. Take the 1, 2, 3. What we have, where we're going, what's our rule, and that should be able to get you there as long as you take it slow, take your time. Okay, bye.